Alrighty, welcome everyone to day 18 of Advent to Code. There was no day 17 video for yesterday. That is because I technically never finished it-ish. The code's pretty close. It works. Part 1, I got part 1. Part 2 is close. I get to 827. My real answer is 829. I was able to kind of fiddle with it and get my real answer, but I couldn't get the code to get me the right answer. But end of the day, basically it's using district's algorithm with a priority queue of sorts. I did some looking at some other people's code for how they kind of went about it. I knew from the start I needed to use this algorithm, but I couldn't quite figure out how to implement it. But with the help of some others that I saw on Reddit and whatnot, I kind of got it working mostly. Sets are very helpful for this. I found out that helps a lot with the speed. And I also saw this nice method for the priority queue, which is basically a list in a list where the outer list is the cost. Technically, I actually don't need this here, and then the inner bit is the actual kind of data that goes with this. So, but at any rate, this works. It should be there. I must have some small bug that I just cannot figure out, but it's mostly there. It gets both examples. It just can't get my code quite right. So I don't know, but that's why there's no day 17, because I've gotten it, but I also haven't gotten it. But at any rate, that's where we're at. Day 18, here's hoping that we can solve this one. Let's see what we have in store. Thanks to your efforts, Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will need a large supply of lava for a while. They also have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, puzzle inputs. The digger starts in a 1 meter cube hole on the ground. Then the specified number of meters up, down, left, or right, clearing full 1 meter cubes as they go. Directions are given from above, so if up were north and right were east and so on. Each trench is also listed okay. When viewed from above, the example dig plan will result in the following loop of trench. Okay. At this point, the trench could contain 38 cubic meters of lava. However, this is just the edge of the lagoon. The next step is to dig out the interior. Okay, now the lagoon can contain a much more respectable 62 cube meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. Won't be large enough. If they follow their dig plan, how many cubic meters of lava can it hold? What was the bit? The color of the edge of the trench should be painted as already. Okay, I guess we don't need it for the part 1. Okay, I got confused by it, but I guess we don't need it yet. Maybe I'm just misreading it. Cool. Sweet. So we're gonna go ahead as most days, go ahead and do input split on new lines, and then map this to then get a line and split the line, this time on spaces, to get our 3 parts. Okay, so that is our instructions, I guess. So what we need to do is follow these instructions, and this is going to draw a map, I guess. So we're just gonna go ahead and do instructions. Reduce. No. Let's position equal x0, y0. We're gonna do this, and then we're actually gonna do is for let I equal 0 while I is less than, and actually we can just do instructions for each I do this, we do need a const of positions. And so we can do positions push position. Okay. And then what we can do here is we need to do position. Actually, it's going to be that, so I don't need to spread it like that. I can just dump it in. It's going to be that equals position dot x plus something position dot y plus something. And it's going to be that. The somethings are dictated by the instruction 0. Yeah, so this is going to be direction and amount. Okay, so direction trying to think if the direction is up, it's going to be equal to otherwise direction 0. So if the direction is up, we're going to add, oh, actually it's not up, it'll be left and right. If it's left, whoops, or sorry, if it's right, we're just going to add amount. If it's left, we're going to subtract amount. And then same thing for this one. These need this. Direction up is going to be actually minus amount, and then down is going to be plus amount. Sweet. It's going to be a %. Okay. So that should give us our positions, and so what we need to do, we just need to know how many are there. So we can use the same logic we used in the previous day for testing if you were in inside that weird windy maze thing. So what I'm actually going to do is I can do is const x max is going to equal to positions. This needs to be as a number. That way I know. Or not as number, it's going to be as that. So it's going to be positions, reduce, and we just need the x max, so it's going to be max position math dot max max and position dot x. Get rid of that real quick. Start at 0, and then the y max y, and then we can do is const map is going to be equal to array from length is going to be equal to y max map, and it's going to be equal to array from length x max. So that'll give us our array. Actually, I can then do another map just to. No, it's fine. So now what we're going to do is we're going to do map equals map dot map. Empty, and this is going to be y. And then inside of this, actually it's going to be line. Inside of it's going to be line, actually return line dot map. And this one will be underscore with x. And all we care about is positions find p dots y equals y and p dot x equals x. If it finds it, it becomes that, otherwise it's that. Okay, there we go. Actually, I can do it that. So now we have this. And if I console log map console log line join on nothing, I should get this, which console.log positions. Right. Okay. What's the X max and Y max real quick? $231 and 8. Cause they go into negatives. Hey. Y min, X min, Y min. Yeah, that would do it. Okay, maybe we don't actually need a map. Okay, so we know half of Doug is actually just positions dot length size. The other half is going to be let positions is going to equal 0, 0 should be in there, right? We're going to bank on 0, 0 being inside the shape. Let's actually get a Q. And then we're going to need visited. Visited is actually going to be this to make our life a little bit easier. And so what we're going to do is while q.length is greater than 0, position is going to equal to q.pop. Break just to make the logic with this happy. So we're going to do is this. We're going to do visited add const pause string is going to equal to position.x position.y so assuming so if visited has that, this is actually going to continue. Otherwise, go ahead and add this, and then we need to check in the 4 directions around it. So we're going to use position const up is going to equal x position dot x, y position dot y minus 1. And what's going to happen is that's up, down, left, right. Left and right. And what's going to happen is if, actually I'm going to make these on a list because I'm lazy. Well, not because I'm lazy, but because I just want to just do this all in one go. To make life a bit easier. For each, we're gonna get the string 2. It's P and P. We're gonna check if visited has the P string here. Return on this. Otherwise, if positions as the string, also return. Otherwise, go ahead and add to the queue. And that should be all, because then we can just do visited.size. And in theory, doesn't run forever because it's the last position. Ah, not I, no I. I bad. There we go, 62. Cool. All right, that works. So if I can leave it for that. Let's try this with our input now. Let's see. No. That seems really high, but it's right. Okay. Well, you know, it's whatever. The elves were right to be concerned. The plane lagoon would be much too small. After a few minutes, someone realized what happened. Someone swapped the color and instruction parameters. I'm producing a dig plan. They don't have time to fix the bug. One of them asked if you can extract the correct instructions from the hexadecimal codes. Each hexadecimal code is 6 hexadecimal digits long. The first 5 hexadecimal digits encode the distance in meters and as a 5-digit hexadecimal number. Last hexadecimal digit encodes the direction. 0 means R. Okay. So const solve. So dump this all into solve real quick. And what am I grabbing out of this? I guess I'm returning positions dot size plus visited dot size. But how am I going to address this for part 2? It's the new instructions. I guess. I can just do part 1. Just give it a boolean. Because then I can flip it on and off here. And what's going to happen is that I have a console log in here still somewhere. Here. What's going to happen is that this is going to change. So const the hex is going to equal to I2. But what's going to happen here is if it's part 1, it's that. Otherwise, if it's part 2, we need to do the hex. We need to do is parse just to make my life a little bit easier. Actually, what was it? 0 is R. Right, down, left, up. Right, down, left, up. Direction is going to be this. And we're going to grab hex some. No, I can just do char at and parse int. I think I can do this. And it's the last one, so it's going to be 1, 2, 3, 4, 5, 6, 7. Char at 7. Hopefully that's right. That was just the direction, and then the amount is going to be parse int of hex substring 1 from 2, 1, 2, 3, 4, 5, 6, 7, 2 to 7, and it's hex, so it's 16. I think that'll work. That'd be a negative. There's gotta be some sort of math to calculate the size of a shape, because it's an enclosed shape. We just need to calculate the area of it. Oh, WikiHow, you'll love to see it. Area of regular polygons, write down the coordinates of the vertices. So what happens is this goes away. So all this becomes is this. We don't even need that. We don't need that. It's just some fancy math. We need the coordinates, which means we need position. Keep going. So we did need position. We do need these. Okay. So instructions, so it gives us a position. So what's going to happen is great. So create. Okay, so 1, write down the coordinates of the vertices. Okay, so we have all of the vertices. List the x and y coordinates of each vertex of the polygon in counterclockwise order. Okay, so now we have them like this. So now we need to follow. Multiply the x coordinate by the y coordinate of the next. So we need to do is lines reduce on step 1, I guess. It's going to be sum. That's going to be line. It's going to be I. What's that? So it's going to be return sum plus line start x times lines I start y. If I equals lines dot length minus 1, it's 0, otherwise I. So that should get us step 1. And then step 2 is the same, but it's the other way around. It's y, that's x. And subtract the sum of the second. So we do return step 1 minus step 2. Zero and 0, nice. I'm gonna guess those are both 0. Okay, what if I don't reverse it? I get the same numbers. Oh, because I didn't do I plus 1. Okay. Of course, that gives a negative number. So we get 84. It should be 62. Oh, I didn't divide by 2. I didn't get to the last step, which is divide by 2. Which is 42, which is still wrong. Alrighty, that took a while to get. I got close a few times. I got really close towards the end when I was talking about this WikiHow about the area of regular polygons. This was right. I was just missing one step, and that was the fact because the problem here. If I go back to day 18. The problem here is dealing with like whole squares, and if you think about it, this formula here is talking about just lines and then the area inside of those lines. Well, we're not really on lines, we're like on the squares themselves, and so because of that, you get to the point where it's like it is the area, but then it's a little more because we're like not inside. It's, I don't know how to explain it correctly, but it is that area of regular polygons. But then you have to go through and get the total distance of all of the dig outs, add 2, divide by 2. That gets kind of, that collects the like the half of it that gets chopped off, because we're going in full squares and not just the perimeter. Yeah. Got there in the end. Both parts now use this. So I mean, to explain this, me for part 1, I basically went through and straight up calculated it just by hand. Got positions, flood filled the interior, and I was good. Part 2, you can't quite do that. There's just too much. So you have to rewrite it, and the efficient way is through, I don't know, is this like an actual, I don't know if this is an actual theorem. I don't know if there's like an actual theorem of what this is like called, or like, but basically I'm just using the area of regular shapes, area of regular polygons, doing this all, doing all the calculations, and then because we're dealing with full squares and not the perimeter, I wasn't even able to figure it out that you had to do the entire distance around, or the entire distance that is being dug out from the problem, adding 2 and dividing by 2 to kind of offset the fact you're digging out full squares at the perimeter. So If there's an actual name for this, let me know. I don't know it, but this is how I got it. It's just a little hard to explain. But yeah. So, anyways, day 18. That was intro. That was something. Yeah. So yeah, there we go. Day 18. Hope you guys enjoyed. See you guys all tomorrow for day 19. Peace.